Hey guys, Mrs. Traver here. We're going to work through our compound inequalities. We've been looking at graphing inequalities as well as doing them with interval notation. So we're going to kind of look at a little bit of both today with compound inequalities. Mainly what's happening here is it's the situation where I have two inequalities kind of graphed on top of each other as an overlap. So let's start off with a graph and we'll work ourselves backwards to the inequality it came from. So if I had this graph that had, let's see, an open dot at -2 and shaded to the left, and a closed dot at 0 and shaded to the right. What it looks like is happening here is if I had two inequalities that were separate, there was this one that was graphed and there was that one that was graphed, and I just did them both in the same number line. So that's really what's happening here is x is going to live wherever I've shaded is kind of the way I think of it. So x could be less than -2. Or x could be greater than or equal to 0. And this is literally how we write this, with the or right in the in-between. So when using these compound inequalities, we're either going to have ors or ands. We're going to do 4 examples of or and then 4 examples of and call it a day. So this one we started with the graph and worked backwards to our inequality. Let's start with the inequality and then graph. So this one is x is less than 3 or x is greater than 5. So on this line, I don't really need to plot a bunch of points on here, but really I just need a 3 and a 5. So I'll give myself that at minimum. And we're going to graph them each individually. So the first one is x is less than 3. That's an open dot shaded to the left. And the next one is x is greater than 5. That's an open dot shaded to the right. So there's the graph where x lives. It's either less than 3 or it's greater than 5. Let's do some ones where we have to solve a little bit first. So say I had x plus 2 is less than or equal to -3, or x minus 5 is greater than -2. So this one there's a little bit more going on. I still have two inequalities with a sign in between, but what's different about these ones is we're going to have to solve first. So on the left, we'll add 2 to both sides. And on the right one, we're going to add 5 to both sides. Go ahead and simplify both those. And we end up getting x is less than or equal to -1, or x is greater than 3. So our plot needs to include from -1 up to 3. I counted by 2's there. There's 0 and there's 2. So I've got a, let's see, closed dot at -1 and shaded to the left. And I've got an open dot at 3 and shaded to the right. Let's do one more of these ors. This one's going to look like x over -4 less than -8, or x minus 16 greater than or equal to 10. All right, so on this one again, we've got two different ones that we have to solve for. Go ahead and take the time here to solve for each of these, and then when you click play again, then we will have our answer. So go ahead and pause now. So when I solved here, notice I took this -4 and I multiplied both sides by it. Because I multiplied by a negative here, I needed to flip my sign. So I have x is greater than 32. The other one was more straightforward. We just added 16 to both sides and got x is greater than or equal to 26. So in graphing these, I need to plot at least a 26 and a 32. And I'm just literally going to plot those two. The first one says x is greater than 32. So open dot, shade to the right. And the next one is x is greater than or equal to 26. So closed dot at 26 and shade to the right. But look at this point. When we get to this point, we already shaded to the right of 32. So this inequality is actually shaded greater than 26, greater than or equal to 26. But this piece is important because x can't be equal to 32. So this one looks a little bit different, but that is also a possibility. So those are all our statements that include or. Now let's do our statements that include and. So here's one of those. I'm going to start off again with the graph, and then we'll talk about what it looks like and go backwards to get our inequality. So this graph has an open dot at -2, and it's shaded to the right all the way up to when it gets to 1, it has a closed dot and it stops the shading. So this one here, if I had drawn an interval, it goes from -2 with the parentheses up to 1 with the bracket. It's kind of like we had two graphs on top of each other. It's kind of like, if you can bear with me here, it's kind of like I went and did an open dot and I shaded to the right, and I had a closed dot here and I shaded to the left. And what I'm looking for here is the fact that I have this overlap. So notice the overlap that I did in red is right in between the two. So my two inequalities I can kind of read by seeing where the overlap used to be. So my first one was that x is greater than -2, but we also have the stipulation that x is less than or equal to 1. So if we put the word and in between here, then we can see that both of these are happening simultaneously. That'll give us a graph that's inclusive between 2 points. Let's do another one. I think it'll make a little bit more sense. So this one, let's start off with x is less than 11 and x is greater than or equal to 3. So on our plot, I'm just going to give myself a 3 and an 11 and call that a day. So let's start with this one. X is less than 11. That'd be an open dot at 11, and I would have shaded to the left. I'm going to start shading to the left, but not really fill it all in just yet. And then the other one, x is greater than or equal to 3. That's a closed dot at 3, and I would have shaded to the right. Now notice, you can already tell these are going to collide. This would have shaded everything past 11, and this 11 would have shaded everything past 3. So the overlap is right in between them. Let's do another. All right, here's our next one. This one I wrote a little bit differently, but it is the same thing. Really, it's saying 4 is greater than or equal to x, and x is greater than -5. So I can kind of split it up into two pieces, but normally you'll see it written like it is above. We can plot both of these. Go ahead and give that a shot and then check your graph with mine. So on this one, we should have had an open dot at -5 and shaded to the right, and then a closed dot at -4 and shaded to the left. All right, here's our last example. We're going to have one that doesn't have the word and in it just yet. Notice, again, if I cover up that piece, I have -14 is less than -11 plus x, and on the right, I have -11 plus x is less than or equal to -12. So I can do those separately. Notice, though, that this one we have to do some solving. In each of these, our only step would be to add 11. So what I'll actually do is add 11 to all three sides. So this one cancels, and then we'll just do some simplifying on both sides. So I've got -14 plus 11 is -3. And -12 plus 11 is -1. So check how I did that, and then let's plot it. All right, so on this one, I'm going to have an open dot at -3, and I would have shaded to the right, and a closed dot at -1, and I would have shaded to the left. So again, I'm inclusive between those two. All right, I hope these look good. We did 8 examples in this video. So the main thing here is looking at ands or ors. Ors are mostly on the opposite ends, unless it's a special case like example 4. And then ands are generally shaded on an inclusive set. Hope this works out, and I will see you later.